Okay, so now we're going to be talking about solving other types of equations that that are in this form of a quadratic. So say I've got something like x plus 3 squared minus 2 times our x plus 3, and then minus 8 is equal to 0. Now, you might be tempted to say, okay, we're going to need to multiply all this out, and then we can figure this out. But if you notice that I've got the same term repeated here, we could do something called a u substitution. And what we're doing here is we're just going to say u is equal to this thing, that x plus 3. Now, you could use a different variable. You could use y, we could use v, we could use w. Just as long as it's a different variable, we could substitute it in. But now, instead of x plus 3 squared, I will have u squared. It's going to be minus 2u, and then minus 8. That's equal to 0. This is considerably easier to solve than our original one was. So what we're going to do is we do this u substitution. We're going to solve this. And this one is relatively easy to factor. This is going to be u minus 4 and u plus 2 is equal to 0. So I'll end up with u minus 4 equals 0 gives me a u equals 4, or u plus 2 equals 0 gives us a solution of u is equal to negative 2. So we solve that. So we substitute. We solve. And then what we're going to do is we're going to back substitute. We're going to replace our original, our substitution with our original thing in here. So we're going to have x plus 3 is equal to 4. So, and, solving this, still relatively easy. X could be 1, or x plus 3 equals our negative 2. Or x could equal negative 5. So we substitute, we solve, and then we back substitute again. So whenever we see something that is quadratic-like, so I see something squared, and plus or minus another thing in that same form, and then a constant. This is something that looks like a quadratic, so we just made this into kind of a simpler quadratic. And we can do this with all sorts of things. Let's do another one. Only this time I'm going to be a little bit sneaky. Say I've got something like y to the 4th minus 5y squared. Actually, no, apologies. Let's not do minus 5y squared. Let's do minus let's do 13y squared, and then plus 36 is equal to 0. Now, once again, we're going to use a substitution and this one's a little bit harder to spot, except that we notice that my coefficients, or my exponents here, are still one set is double the other. So what I'm going to say is u is going to be equal to y squared now. That means that if we were to square this, it means u squared would be y to the 4th. Now when I substitute this, that means I will have u squared minus 13u plus 36 equals 0. This I could solve. And I've got a factor pair of 36 that adds up to be negative 13. And without being too dramatic about it, I'll say minus 4 and minus 9. Those would add together to be 13, multiply together to be 36. So this is going to be u minus 4 times u minus 9 is equal to 0. So now I've got u minus 4 equals 0, gives me u is equal to 4, or u minus 9 equals 0, gives me u equals 9. So this is my intermediate solve. And then I can, once again, back substitute. And this one looks a little bit weird, but take a look at it. We're going to have y squared equals 4. And then from here I can, or y squared equals 9. And I can subtract 4 from both sides. I'll have y squared minus 4 equals 0. I can factor this to be y minus 2 and y plus 2. And I've got y is equal to 2, or y equals negative 2. Very similar with this. I've got y squared minus 9 equals 0. This is going to give me y minus 3, y plus 3 is equal to 0. So I would have solutions of 3 or negative 3. So I've found one equation with 4 different solutions. And that's something that will frequently happen is if you've got a 4th power, you can have up to 4 solutions. If you've noticed that if you see something with a second power in it, you can have up to 2 solutions. And of course, if it's just linear, so there's no power, only one solution. Alrighty. That's all I've got for right now. We'll see you in the next video.